Hello students, in this video we are going to see one interesting question which is given in your textbook in exercise 5.2, 15th question. So very interesting question. So when we work out this question analytically, it is a 5 mark question. We have to do several steps, but using graph, by understanding the concept, we can solve this question very simple. So listen carefully. Here PQRS is a rhombus. PQRS is a rhombus. See, the diagonal PR and QS, the diagonal PR and QS intersects at M. So this is the the diagonals are intersecting at the point M and satisfy QS is equal to 2PR. QS is equal to 2 times the PR, which means the diagonal, the first diagonal, we can take this diagonal as D1. The first diagonal QS or SQ is equal to the D1 is equal to 2 times the D2, second diagonal. So from this we can say D2 is equal to half of the first diagonal. The second diagonal is half of the first diagonal. So here I have drawn like this, but actually the triangle, the rhombus, it is like this. It is so P, Q, R, S. Diagonal D1, this is diagonal D2, this is M. So now diagonal D2 is small, D1 is big. 2 times of this diagonal D2 is equal to the diagonal D1. Do you understand? Okay. Now 2 coordinates are given. What are those 2 coordinates? S and the M. So S 1 comma 1 and M 2 comma minus 1. So see, this property we all know familiarly. The diagonals of a rhombus bisects each other at right angle. So the diagonals bisect at right angle. So here the angle will be 90 degree, and this distance SM and QM will be equal, and this distance will be equal because they are bisecting each other. They are dividing each other into 2 equal parts and meeting at right angle. Okay, let us take this diagram to the Cartesian plane. So this 1, 2, 3, 4. Minus 1, minus 1, minus 2, minus 3, minus 4. 1, 2. So this point is 1 comma x square 1 comma 1, that is 1 comma 1 is M. Then 2 comma minus 1, this is M. So we have this line. Only we have this line. So this SM will be equal to MQ. SM will be equal to MQ. So the Q will be here. See, here I have taken 2 rectangles. Here I have taken, here also I have taken 2 rectangles, 2 squares, so it is a rectangle. Here also I have taken 2 squares, it is a rectangle. So the diagonal of will be same. So these 2 will be equal because this is diagonal D2, D1. See, diagonal D2 is half of D1. So the entire diagonal is D1. This is half of these are all halves of d1. So the length of this half diagonal will be the length of the second diagonal. If we take this line and we can keep this in a right angle position, and we can say that the line segment is the second diagonal, because d2 is half of d1. So and also the diagonals are intersecting at right angle, so the next line must be a right angle. I am just drawing a perpendicular line. See, I just draw these two are here 90 degree. You can use, when you are drawing in your notebook, you can use the protractor and you can draw. So this is the perpendicular line to the diagonal. So this, the d2 must be lies on this perpendicular line. The length of d2 is half of d1. Length of d2 is half of d1. So this half I am taking, see, this is the length of, here you can see, if you have a measuring scale ruler, you can measure it, see, exactly same. So this is the rhombus. This is the rhombus. So this is M. This is not M. 1 comma 1 is S. This is Q. S, M, Q. Then the vertices are P here. If P is here, P, Q, or S. So P is equal to, therefore P is equal to, what is the coordinate? X axis 1, then y axis 1, this is 2. In between minus 1 and minus 2, minus 1.5, which can be written as 1 comma minus 3 by 2. Half of 3 is 1.5. So I have, here I have written as decimal, here I have written as fraction. This is the value of P. Sometimes P may be here, P, Q or S. It may be like this. So if P is here, what is the value? X axis 3 and y axis between 0 and 1, 0.5, that is 1 by 2. Under the x axis, so minus. So P is equal to 3 comma, if you are writing as decimal, this is 0.5 minus 0.5. If you are writing as fraction, minus 1 by 2. So these are the possible coordinates of P. So therefore P is equal to 1 comma minus 3 by 2 or 3 comma minus 1 by 2. So this is the graphical way of solving this problem. Very interesting, easily we can understand. So if you are working this problem as in analytical method, it may take some time, we have to work out lot of things. But if you understand the concept, not only this question, all the questions which is given in the coordinate geometry can be solved like this. Even the equation of a line, slope of a line, inclination of a line, all the problems can be solved using this method. So the name of the lesson is coordinate. Coordinate, where it will be? It will be lies in the Cartesian plane, coordinate plane. So definitely using graph sheet we can solve all the problems which is given in a quadratic coordinate geometry. Thank you.